Okay, number 12, a 3 centimeter diameter wire coil with 25 turns and resistance 0.015 ohm is placed coaxial inside the solenoid. The solenoid with diameter 6 centimeter and the length 20 cm and 1000 turns carry the transcurrent 14 ampere per second. So okay, so first is to calculate the maximum flux passing through to the coil. So now the first you have this is the solenoid here, and you have the current flow in the solenoid is equal to what is the I? So I is a so this is a transfer current is 14 ampere per second. Right, this is the current, and you have a coil. Say I draw the coil here. The coil here is this is a number of turns 25, and number of turn of solenoid is 1000, and the length of the solenoid is 26 centimeter and diameter 6 cm. Okay, so when the current flow in the solenoid, so now you have a flux or magnetic field produced by the current, right? So this is the flux. So the question asks you what is the maximum flux passing through to the coil. So what is the maximum flux? Flux through the coil. So now if you look at the equation, so this is B. First B for the solenoid at the center, so the BS is given by the equation U naught and I over L. But flux for the is given by the equation B time area A. So the B here is because this is solenoid, so at the center BS, and the A area is referred to the area for the solenoid. So and the BS is equal to mu naught and I over L times A. So the value of the mu naught is a constant, so this is 4 pi exponent minus 7, and the number of turn of solenoid is 1000, right? And the current flow is equal 14, and length of the solenoid is 26, meaning convert to the meter is 26 times 10 power of minus 2, and the A is area solenoid is pi, J or radius square is and the J, because the question gives you the value of the diameter, mean half, this is 1.5 exponent minus 2 meter, so you can find the pi J square here. So all the value here, you can use the calculator to find the value of the maximum flux passing through to the coil at the center here inside the solenoid is equal to use the calculator, this is 4.8 exponent minus 5, the unit, this is minus 5, unit is a Weber, right? So this is a flux, maximum flux. Next, question number 2, calculate the current induced. So you can use the current induced. Current induced is come from the, because we EMF is equal to current induced times R. So the current induced is equal to induced EMF divided by R. So now this is number 2, right? Induced EMF in the coil is a number of turn coil times the rate change of flux and divided by R, and number of turns of the coil is equal to 25 turns, and the rate or the flux dt is equal, and the flux dt is come from the, this is the flux, the flux, this is 4.8 exponent minus 5, and the resistor is equal to 0.01 ohm. Now you can find the induced currents. So current induced is equal to 0.08 ampere. And next, question number 3, what is the effect of on induced current if the coil is slightly stressed? Explain answer. So the answer is the effect on the induced current is no change, right? So the answer is no change. Why? So this is because of when you stretch the coil, you don't have the change of area A. So meaning the value of the flux is not changed, meaning the value of induced current stay the same. Thank you.